Today we're going to talk about composite functions, which is made by putting two functions together in a rather interesting way. So what we have, we would write the composition of two functions as f composed with g. So we would say here f composed with g and apply that to x. Another way to write this is f of g of x, and we would say f of g of x. So when we're composing two functions, essentially the outputs of one function become the inputs of the other function. So here, this is the output of g, which is also the input of f. So we are composing, we are taking what comes out of our g function and putting it into the f function. Okay, so an easy way, so one thing that comes out of this, we'll have a look after we do our few examples, is this has some implications about the domain and the range for f and g. Okay, so let's just take a discrete function on a couple of points. So let's say g of x maps 1 to 2 and 3 to 4. Then let's say f of x maps 2 to 7, 3 to 8, and 4 to 9. So what we want to do is we're going to find f, I don't know what that was doing, composed with g of x for, let's try it when x equals 1. Okay, so what we're going to do is we're going to do f of g of 1. So we do g of 1 first, the inner function comes first, and then we're going to take f of our answer. So g of 1 gives us 2, so we're going to take f of 2, and that is equal to f maps 2 to 7, so our answer is 7. Let's see what happens when x equals 3. So notice that we have to pick x values that are in the domain of g of x, otherwise we won't be able to apply g to that function. So we have f of g of x. Okay, so we're going to do f of g of 3. G of 3 is 4, so we're taking f of 4, and f of 4 is 9. All right, so let's look at a function that's not discrete. Okay, so we have if f of x is 1 over x, and g of x is x plus 2, and h of x is x squared plus 1 squared, let's find f composed with g composed with h. So we are trying to find here f of g of h of x. Make sure we have all our closing brackets. Okay. So this is going to be f of g of our h of x, which is x squared plus 1 squared. And I'm going to make sure we have nice brackets around that and there. Okay, so we're taking g of x squared plus 1 squared. So g of x is just x plus 2, so all we're going to do is add 2 to that. So this is f of x squared plus 1 squared plus 2. Now we're going to take f of that. F of that is putting 1 over that function. So it is x squared plus 1 squared plus 2. Now, notice that f, because we have an x in the denominator, we should have to restrict the domain, but here we don't, because the range of my h function is that x is always positive. It's always actually going to be greater than or equal to 1, no matter what we put in. That we don't need to worry about restricting it because our denominator can never be 0. So actually the domain of f composed with g composed with h is all real numbers, even though the domain of f of x is not all real numbers. So the domain of a composition of functions sometimes is different than the domain of some of the individual functions within that composition. Okay, so notice when we have a composition of functions, so for this one, the domain of g of h of x is the range of g of x is the range of h of x. So the outputs of h of x become the domain or the inputs for g of x. Okay. So let's look at going the other way. And in calculus, a lot of times what we're going to be doing, rather than composing functions, just for the fun of it, we're going to be looking at functions that are created as a composition of more than one functions. And we're going to have some special computational techniques we're going to need to use for functions that are a composition of functions. So let's find a couple of functions. And in this case, order really matters. So let's say we have f of x equals 1 over x minus 6. Okay, we want to find f and g such that, so this is such a nice little abbreviation for such that you will often see. Find f and g such that f composed with g of x equals f of x. So we want to take our f of x and we want to break it down. Here. Yeah, we'll leave that little equal sign in there. It's not going to hurt anything. So what we want to know is what happened to x first. So the first thing that happened to x is that we took the reciprocal, and after that we subtracted 6. If we had subtracted 6 first, it would also be in the reciprocal. So we know the first thing we want to do, which is reciprocate, that's going to be our g of x, because the second function, when we're writing it in that circle form, always is what has to apply to the x first. So we know that g of x has to be 1 over x. So now we want to find f. So f of g of x will take our g of x and then do something else to it. So f of x, not f of g of x, but f of x is just going to take x and subtract 6. Now this can get a little bit confusing because you're using x in 2 different ways. Here, x is the input of g, right here. And then here, x is the input of f. And we have to remember that we're using 1 over x as our input for f if we want to do f composed with g. Let's look at one. It's a little bit more complicated, where we're going to try to break down 3 functions. And we have to actually go cast our minds way back to about Math 9, or maybe even Math 4, grade 4, something like that, where we're doing order of operations, because we have to be careful that we're having our functions happen in the correct order. So if f of x is 1 over absolute value of x plus 3, we want to think about what happened in what order. So what was the first thing, second thing, and third thing? Okay, so we want to find f, g, and h such that f composed with g composed with h equals big F. Okay, so our h is going to come first. So we look at what happens first. And the x is within absolute value signs. If we had added the 3 first, it would be inside the absolute value. So the very first thing we did was absolute value. Our So our first function is the absolute value of x, and that first function is the last in our composition order, or our h. So we have h of x is the absolute value of x. Then what happened? Well, remember when I said if we had in the last function, if we had subtracted first, it would be in the denominator of our fraction. The second thing we did is we did plus 3. So we took x, we added 3, and that gives us g of x equals plus 3. And then finally, our last function is going to be our f of x, and that's where we took our 1 over x. So those are our 3 functions that we have to deal with. So hopefully you will be able to both compose and decompose functions after this.